Welcome to a technique video. Today we'll talk about HCF and LCM. In the fraction tutorial we'll need them to work with fraction. So let's see how do we find them and what are them. So HCF is short for highest common factor. So what are factors? Okay. So factors are some numbers which are positive integers multiplied together to form the number. For example, 12 could be expressed as 1 times 12. Can also be expressed as 2 times 6. Can also be expressed as 3 times 4. So all of these 6 are factors of 12. 1, 2, 3, 4, 6, 12 are all factors of 12. So I didn't write 1 here because every number has the factor of 1. So, but the 1 is still a factor of 12. And for 18, we can do the same. 18 could be expressed as 1 times 18, or 2 times 9, or 3 times 6. So these 6 are all factors of 18. 1 is not written. So among the factors of 12 and the factors of 18, these 3 are common to both of the numbers. So we have 2, 3, 6 are common to both of them. So these are their common factors. And we're looking for highest common factor, which means 6. Okay. This is what HCF is. Then look at LCM. So LCM is short for lowest common multiple. What multiples? So multiples are products of the number multiplied by a positive integer. So 12 times 1 is 12. This is 12 times 2, 12 times 3, 12 times 4, etc. This is 18 times 1, 18 times 2 is 36, 18 times 3, 18 times 4, etc. Every number has an infinite amount of multiples because we can go infinitely large. So we're only listing the lowest one. And among these multiples, 46 appear on both of the lists. So it's a common multiple, also 72. And the lowest common multiple will be 36. Okay. So this is the first method, the natural method to find the HCF and LCM. Okay. And for the second method, first we need to know what is a prime number. Again, among positive integers, prime number can only be expressed as 1 time itself. For example, 2 is 1 times 2, 3 is 1 times 3, 4 is not a prime because 4 can be expressed as 2 times 2 and 1 times 4. 5 can be expressed as 1 times 5 only. 6 can be expressed as 1 times 6, but can also be expressed as 2 times 3. So not a prime. So we can go on, and there is no largest prime number. Okay. So, but knowing this field will be quite helpful up to 19. Okay, so now, oh, by the way, a 1 is not a prime number. It's defined this way for our convenience later. So actually the full definition is 1 times itself, and these two numbers have to be distinct. Okay, cannot be 1 times 1. So now we look at the second method. We have 12 and 18 again. So these are divisions. This means 12 is divided by 2, which is equal to 6. And then I do a second division using this 6. So 6 divided by 2 is equal to 3. This is the second division. So if we use this symbol, then we can like do it like continuously, right? Just go on. Yeah. So that's why we're not using division like the original symbol. We're not using this here, although they mean the same thing. So then, yeah, and then if we do this to 12, although when we're doing divisions, we can only use prime number. And since we only use number that will make the number divisible, so these are also their factors. 2 is a factor of 12, 2 is a prime number, so 2 is the prime factor. After doing this, we have 12 is equal to 2 times 2 times 3. And 18s, doing the same thing. 18 divided by 2 is 9, 9 divided by 3 is 3. We have 18 is 2 times 3 times 3. Okay. And from this prime factors multiplication, we can figure out the HCF and LCM. So like here, we recall the HCF is 6. Right? So how do we do this? So if we look at the prime factors, 2 is common to both of them. The first 2 is common. The first 3 is also common. So we multiply the common prime factors, 2 times 3, and then we have 6. Notice that the second 2 of 12 is unique to 12. 18 do not have the second 2. And the second 3 of 18 is also unique to 18. The 12 do not have a second 3. And that's why we are not putting them in here to work out the HCF. Okay. Using these, we can also find out the LCM. So if we recall previously, these two has the LCM of 36. And here we have to do 2 times 3 times 2 times 3. Okay, this 2 times 3 is the HCF. We're doing exactly what we did, but with more. So what's more is that we multiply the unique prime factor into the calculation 2. The second 2 also here. The second 3 also in here. Okay. Then this is 2 times 3 is 6. 6 times 2 is 12. 12 times 3 is 36. This will be the LCM. Okay. So why is it like this? Why these two methods yield the same answer? So let's briefly go through this. So basically, 2 times 3 6 is like the largest number where they have something in common. So for example, 2 times 6 is 12. 2 times 9 is 18. So 2 is still common to them. 6 times 2 is 12. 6 times 3 is 18. Then it's still common. But larger than 6, then we cannot find a number that is like common to both of them in their history of like forming the number. Okay. And for LCM, so 6 is their like latest point of common. So then we multiply by 2 and 3 again, then they will join again. So 2 times 3 is 6. And then 6 times, this is a 6, this is the HCF. HCF times 6 is 36. So 12 times 3 is 36. So, and 18 was a 6. And then 6 times 6, 18 times 2 will be 36. like 6 times 6. So then 18 times 2 is 36, 12 times 3 is 36, then they meet again. This is the soonest they will meet. They also meet with later, but those numbers will be larger, like 72. Okay, this is how the HCF and LCM work. And we'll see you in the tutorial video. This is for the LCM and HCF.